Hey, good evening everyone. So today we are going with our next topic, that is our Oracle database architecture. So let's move with that topic. Okay, this is how architecture looks like. This is a diagram that we have already discussed in our last session. This is something brief that is we are going to discuss today. As we have discussed in the last session, that the first component is our SGA. This is the memory component, and memory component has two composition, two subgroups. Number one is SGA and number two is PGA. So in this sections you can see SGA is there. This is a system global area. Under SGA we have the shared pool, and under shared pool we have two components. Number one, library cache. Number two, data dictionary cache. We have few more other components like server, result cache, others, reserved pool, that we are going to discuss in the later section. The most popular thing that is present in our shared pool that we are going to discuss today. Apart from that, we have a large pool and database buffer cache that we have discussed in the last sessions, redo buffer cache, fixed SGA, Java pool, stream pool, and all that thing. The second memory component is PGA. Under PGA we have few more components. Sub-components is SQL work area, session memory, SQL private area, and all that thing. Apart from that, we have some few background processes. Number one is pmon, smon, reco, mmon, mmnl, others. These are the background processes. The most popular background processes are dbwn, ckpt, lgwr, archiver, and rvwr. So today we are going to discuss in brief, and one more thing you can see here, it is written instance. Instance means only SID, that is system identifier, and SID is equal to the SGA component, the memory component plus background process. So remember this thing whenever you are going to work in organization. You might be asked in the interview about SID. What is SID? So these are the components of memory architecture as well as the background processes and the storage. So the first topic for today's uh, day is the database server. So what do we mean by database server? In our case, we have our VM machine, and under VM machine what we have done, we have just installed the operating system, then we have installed the DB softwares, and on the top of it we have installed the database. So this OS, database software and database is installed in some virtual machine. This virtual machine is nothing but what we call as a DB server. If all these things is installed in the virtual machine, then we can say that okay, this is a Linux VM if Linux operating system is installed. If there is some physical servers, then it can be named as a physical server. But in most of the organizations, the servers is being considered as a Linux VM. So keep in mind that if Linux is installed on any of the server or virtual machine where operating system is Linux or Red Hat or whatever Linux is, and the database software is installed on top of that, and DB is installed, whatever the version it may, by 19C, 12C, 11G, so it can be considered as a DB server. Where database is installed is known as database server. For considering database server, we should know about hostname and IP. Suppose, say you are going to work with an organization and some of your seniors asked you that please log into this database server. So how can you differentiate between they have sent you an email, and in that attachment you have find the list of servers, and on that server list you are getting 500 plus servers, and your senior is asking to log in one of the servers. So how you can identify it? To identify it only, you should know these two things at least. Not these two things, either you should know hostname or IP, because hostname or IP only makes a database server unique. To uniquely identify the database server, the unique hostname and IP should be present. Suppose if your server name is let's say BXOYKOL01, this is your server, and the domain name can be anything. but this is your server name. So with this you can log into a machine. With this server you can log in, and suppose someone has stated okay, log into this host name, or they have shared you the IP that 192.168.0.10. This is the IP. Log in here. So you can't log in directly by knowing the host name and IP. If you want to log in, you should have some tools. And what tools you should have? There is most popular tools is Putty. You can use SQL Developer also. From Putty you can log in with SQL plus utility, and there is another tool that is called a SQL Developer. You can log in with a SQL Developer also. But keep in mind, with these two tools also you will be able to log in to the DB servers only and only if you will know the username and its credential. So you should keep in mind that the database server, we have operating system, database software and database is installed, whatever version may be, it's called a database server. Or if it is installed on VM, top of the VM machine, then it can tell as it is a Linux VM, or what we call as a database server, which is a Linux VM. If it is in physical servers, then you can consider as a physical server. And if someone is saying please log into a database server, so how to understand that which server we have to log in? You can identify it with the help of number 1 host name, number 2 IP. If any of it is given to you, then you will be able to log in with the host name or IP. And hostname and IP only makes the database server uniquely identifiable, so that we can log into the database server very easily with the help of multiple tools. And one of the two most popular tools is there, that is a Putty. With the Putty we can log in with the SQL plus utility. It is a CLI, command line interface, and another is SQL Developer. And with these two tools you can log into the database server, but be sure you should know the actual current password as well as the username. Without the username and password you won't be able to log in with the within the database servers, even you have the tools access. So whenever we are talking about database server, there is some processes in between. You can see here that this is a database instance, and in database instance we have understand that okay, database instance means memory portion plus background processes. If someone or any user wants to log into the database instance or want to fetch some query, some DDL or DML they want to perform, then they have to undergo n number of parameters, n number of processes. How to do so? This is what we call a client application, the client process. So client means what? You can say as a layman, it is an application team. Whenever you are going to work with an organization, you will be getting DB team, application team, network team, operating system team, what we call as server ops, and multiple teams are there. The VM team is also present on that your company. Storage team also there. So in as a layman you can say this is the application server, and from application server only one can process a SQL statement. One can log in with the application server, and with the help of application server only you can trigger a query. And suppose some application team has triggered a SQL query, whatever query it is, whether it is DQL, DDL or DML. So while firing the query, by triggering that query, the process in between is listener. What is listener in brief we will discuss in the later section, but listener as of now you can understand it is a process. So what listener does, it understand what client is requesting to us, because application server, application team or client team is processing or triggering a SQL query. So listener tries to understand, okay, this is the client requirement, and understanding the client requirement, listener helps in connecting with the database instance. So listener is a mediator which listen to the client request and makes the client able to connect to a database instance, so that they can easily do the connectivity and they can do the transactions. Because as a DBA you should be knowing that okay, one should connect to the database servers and can perform transactions, but in in transactions term, the application team only triggers a query and it reaches to database servers with the help of listener process. If listener process is up and running, then it can connect to the database. If listener process is down, then even you fire the query from application server, you won't be able to connect to the database instance. So once our listener process is up and running, you are good to connect with the database server, and after connecting, you can fire insert, you can fire update, delete, create, alter, drop, whatever thing you want to do. And if you are doing insert, update, delete and doing commit, that means you are doing some transactions. So that transactions will be stored in the database. And the database is what we call as a storage entity, and the storage entity is known as data files or system files. So in this diagram, you can understand that on Oracle database consists at least one database instance and one database. In this diagram, you can see that this is one instance, and in below where data is actually saved after a commit or successful transactions, there should be one database. It might be the database instance can be multiple, but in our case, if you are studying about standalone servers, it should be only and only one instance. And in database, you can see there can be multiple files. Even it is a data files, and it can be 2 data files, 3 data files. There can be multiple data files along with the system data file. And if it is a rack, then it should be mandatory that you have multiple instance. This is only one instance, DB instance. If it is a rack, real application cluster, then there should be one more instance, what we call as a 2-node rack. It is a DB instance too. But the database should be only one. Database should be only one. Only difference in rack is there will be a multiplexing of instance. That's it, nothing more than that. And in future we are going to study about listener in deep. Then you will be able to know what is the purpose of listener is, because listener is a database server process. It's basically listen the client request, establishes the connections to the database instance, and then hand over the client connection to the server process. The listener can run locally on the database server or run remotely. Typically, Oracle RAC environment are run on remotely basis, but in standalone, it will run locally. So this diagram specifies this much informations about the database server, about the listener processes, how you can do the connectivity, who fires the SQL query. Here client application team fires the SQL query, and the SQL query only reaches to the database instance when listener process is up. If listener process is down, then you won't be able to do the connectivity. Listener, just consider that this is a process which requests the client request. It receives the client request, and once it receives the client request, it helps in establishing the connection with the database instance. If this listener is only not there, then who will listen the client request? Even you are firing or triggering a query, no one will listen your request, and you won't be able to do the connectivity with the database instance, and you won't be performing any operations. So its listener is just a database server process who listens the client request and establishes the connections. And the database server, what we used to say that it's just a server which consists of one database instance. An instance is a combination of memory and the database process, and it should have one database at least consisting of data files and system files. Moving forward, next topic is database instance, and the database instance is nothing what we call as a SID. SID means system identifier. So in a database instance, it contains the sets of Oracle database background process and memory components. So you can see here, this is the background processes and this is the memory component, the SGA component as well as the PGA component. So here the background process operates on the stored data files. Whatever thing is present in the database is just a physical, you can say that it's a logical entity. But the files inside the database are physical, what we call as the data files, control files and redo log files. So the data files and all the storage medium are physical entity, but database as a whole is a logical entity. So whatever query you are triggering or whatever functions you are triggering, it just gets stored in the database only and only with the help of the background processes. And database instance only what we call as a combination of memory and the background process. And memory structures are, you know, that it is the SGA, that is the system global area, and number 2 is the program global area. And one more thing you should understand, if you're talking about logical memory or physical memory, then you can surely short you can say that database instance, it allocates the memory, that means is a logical one, and the instances only and only exist in the memory. There is no physical significance of it. It stores a logical memory, and the instance will be created on that memory, so that you can view the SQL records, you can view the database objects, and you can even trigger it, even you can do the DML operations, DDL operations, everything. All the physical files will be reached to this database instance in the memory segments, and you will be able to view that components. So this is what a database instance is. Apart from that, if you will trigger any of the SQL query, and the SQL query will be fired from the application, and application team will trigger the SQL query, and once the listener is up in between, once the listener is up and running, listener helps in requesting the client request and establishes a connection with the database instance. Once the database instance is being connected with the client request, whatever SQL, even update, insert, delete query will be triggered, it will reach to the database instance and will be processed. So whatever query you are triggering, you will be able to view and do insert, update, DML, DDL, DQL, everything in the memory. That is why I am saying that SID, that is the database instance, exists in the memory, and it is a logical entity. There is no physical significance of it, and the instance is a combination of memories and database background processes, and all these things will be maintained in the database. Whatever transactions the client team is triggering with the help of the SQL processing, everything after the commit will go to the database, because each and every records will be saved in the database only. Moving forward, system global area. In the past we have discussed about the SGA component, this SGA component, and one of the subcomponent of SGA was shared pool, redo buffer cache, database buffer cache, large pool, Java pool, and multiple pools are there. But today we are going to learn about the system global area, what we call as a SGA, and SGA is a memory area. So you can say system global area is a memory area that contains data and all control information for one Oracle database instance. What is mean here, that it is a memory area. You guys are knowing now that this is a memory segments, because Oracle is categorized into 3 components. Number 1 is memories, number 2 background process, and number 3 is storage. So number 1 is memory component. Under memory component you have 2 subdivision, that is SGA and PGA. So you guys are familiar with the SGA part. SGA is a system global area, and you can say, okay, we are known with the full form of SGA, that is the system global area. What next? What information does it contains? So it will contains data and control informations of Oracle DB instance. That means what? All the informations, what query you are triggering, all the information related to in-memory area, all the information related to the database objects, each and everything, all the data, each and everything will be captured in the SGA. But what is happening in the redo the buffer cache? What are the redo entries currently available? What is the current block, which is pinned buffer, dirty buffer, or it is a clean buffer? Which type of buffer is currently used by redo the buffer cache? That will be stored. What is the current plan hash value? What is the execution plan? Which query is doing hard pass? Each and everything, whatever component is present under SGA, everything will be captured and controlled by SGA. So it contains all type of data and the control information for a Oracle DB instance. Even the server process as well as the background process share the SGA. So you can say that the server process and the background process will use the SGA, Because in case suppose if you want to capture some data and you want to write to the disk, this is the memory segments, and in process there is a BG process, background process. If someone has done commit, so it should be written in the disk na? Until unless you won't be write in the disk, what we call as a database, it won't be saved. So it's better to write in the disk on the regular interval, and this writing the information to the disk or after committed transactions will be done by the background processes. So that is why I'm saying that server process and BG process also shares the SGA. So it consists of multiple components. Number one is shared pool. Under shared pool, you will be seeing that there is two components, that is library cache and data dictionary cache. But as of now, we are going forward with the shared pool only. So the shared pool, it caches various constructs that can be shared among the users. What does this mean? That means the shared pool stores all the past SQL and PL SQL codes. That means the importance of shared pool is it stores all SQLs and PL SQL codes. Why it is storing, what is the SQL codes, what is the PL SQL codes, we will discuss each and everything when we will be familiar with the library cache and data dictionary cache. But as of now, you should understand some type of code, some type of SQL statements will be captured in this shared pool. It's not that only SQL and PL SQL code will be residing here. There can be a system parameter also which will be stored here, system parameter. Apart from that, there must be you can say data dictionary information is also present. Data dictionary information is also present in this shared pool. Whenever you are executing a SQL statement, so the Oracle database access the shared pool. Without accessing shared pool, you won't be able to execute any query. So it's the mandatory it's the mandatory subcomponent of SGA. Whenever you are triggering any query, it should go through this shared pool. Without accessing this shared pool, it won't go, because it stores procedures, PL SQL codes, system parameters, data dictionaries informations, and each and everything. Next is the flashback. Flashback is an optional component in SGA. When flashback database is enabled, the background process called RVWR is started. You can be aware with RVWR. This is the background process which will work only and only when you will start and initiate the flashback. And you will say, okay, what is flashback database, what is enabling, what is disabling, how to enable, how to disable, that we'll discuss in the later sections. But as of now, you should know the flashback buffer is just a optional area in the SGA. It resides in SGA component only, and it's an optional area. And whenever you are going to start or enable flashback, it will initiate the RVWR background process. You can say that this RVWR periodically copies modified blocks from the buffer cache to the flashback buffer, and sequentially writes the flashback database data from the flashback buffer to the flashback database logs. That's it, nothing more than that. There is one more component called in memory area. This is new memory component which has been added after 12c. One is database buffer cache, which is very important. We will be studying in more detail on this. Next is redo log buffer cache. In redo log buffer cache, as of now you can understand it carries or contains redo entries. All the redo entries is being captured in the redo log buffer cache. You can say whatever DML operations application team is firing or DDL operation is firing, the statement, the complete statement will be captured in the redo log buffer cache in the form of redo entries. But you will say, okay, if you have fired some select statement DQL, this will not be stored in redo log buffer cache. Only the DML and DDL statements will be existing or residing or stored in the redo log buffer cache. Next is a large pool. Large pool is an optional memory area, and it is used for you can say the backup and recovery purpose. Whenever you are using rman utility tool for doing backup and recovery task, or you can say if you want to defer the inserts, you can use this large pool. We'll discuss each and every component in more details, but as of now, our main objective is to learn about this shared system global area. So these are the components, these are the things that resides under shared system global area. Next, you can say the Java pool. All the Java related codes and everything is present under this Java pools. If Java query is firing using the Java virtual machine, that is a JVM, you have to create a sessions related to that. If Java related query you are firing with the Java virtual machine, a specific session should be created, and that session should take place that session should consume some memory area, that is the Java pool only. It won't impact other memory component. It will go and directly create a sessions for Java related code, Java related sessions. And the Java pool memory is used in different ways depending on the mode in which the Oracle database is running. So be sure that whenever you are running Java related informations, the Java session will be created under the Java pool. And fixed SGA, the last one, is the internal housekeeping area, which containing general information about the state of the database and the database instance, or the information that is communicated between the processes, all the background processes. So it's a simple fixed area which contains extra information, nothing more than that. So this is what we have to learn in system global area. Moving forward with program global area, this is the PGA component. Under PGA component, this is also one type of memory component of the Oracle database instance. Under this, we have many subcomponents known as UGA, SQL work area, short area, session memory, variables, sessions, OLAP pool, and all that thing. But as of now, we will skip this topic because in detail we are going to learn in our next sessions. So moving forward with the background processes. So these are the background processes which is very, very important and you should be knowing about. Each background process has its important significance. Like pmon is functionable with its own operations, pman does its own operations, smon is very important in instance recovery, ckpt, mmon. Why I'm showing the slides? Because you should know about the background process name. At least name should be aware with you guys. It should not happen that in later sections you will be not knowing the naming convention also. If someone will say what is ckpt, you will be blank. No, on that scenario you should be knowing about the background process name at least. So background process is also very, very important because these are the part of the database instance and perform maintenance tasks required to operate the database. Each background process performs a unique task but works with the other process. Suppose if you want to capture data from the SGA, that is the memory locations, this is the mediator. If you want to capture some information from memory area and you want to save it in the disk, so the responsibility of doing this is for the background process. So background process should be very, very important and it should be always running whenever you started the database instance. So the mandatory background processes are present in all typical database configuration. By default, you can see smon process. Smon is a system monitor which helps in instance recovery. If sometimes instance get crashed, so you can recover it. Then the next process is pmon, that is a process monitor. Then it is a pman, that is the process manager process. LREG, that is listener registration process. Then dbwn, database writer. ckpt, checkpoint. mmon is a manageability monitor process, and then reco is a recovery process. lgw is a log writer, and rest, the archiver, cj, these are the optional process. And suppose if job queue coordinator process, you can say if job is in a queue, then you can use this process for doing all that operations. If recovery writer process is failing, you can check the RVWR recovery writer process whether it is running or not. Then FBDA, this is what we call as a flashback data archive process. And the final is SMCO. SMCO is nothing but a space management coordinator process. It always maintains and manages the space related thing. and these are the slave process. We are not going to deep on this because it is not related to our task, our DB activities. So as of now we can keep up to here only. We will meet in the next session to learn in more details about next topics. Thank you everyone.